Hello students, welcome to Mass Academy. This video is revision for term 3 examination for grade 9 advanced. In the first part of the video we have discussed first 4 concepts of the EOT, and now in this video we are starting with the concept number 5, that is conservation of energy, and we have 4 questions from this topic, that is question number 4, question 9, 11 and 17 of EOT are from this topic, that is the conservation of energy. So we will start with the question number 4. Question number 4 is state and explain law of conservation of energy. Law of conservation of energy states that energy cannot be created nor destroyed. Energy can change from one form to another. For example, here we have, okay, this is our ground, this is the ground. So ground we will consider the height is 0, okay, at ground the means it is 0, we will mark the height as 0, and here at this height we have a ball here, at this height there is a ball. There is a ball here and the mass of this ball is 1 kilogram. 1 kilogram is the mass of the ball, and this height is 2 meters from here, from the ground to here the height is 2 meter. And we will consider the value of G, the value of gravitational field is 9.8. So we will just consider for ease of the calculation, for easiness of the calculation, we will consider G equal to 10 Newton per kilogram. So what is the potential energy of this ball at this height? The potential energy of the ball, that is equal to, potential energy of the ball is equal to mgh, right? How to calculate potential energy? Potential energy, the equation is mg multiplied the change in height, that is the delta h. Mass of the ball is 1 kilogram, and what is the value of G? The value of G is 10. We are taking it 10 for means to make the calculation simple, and the change in height, the height is like 2 minus 0, right? So 2. So the potential energy of the ball is 20 joule when the ball is at this height. So the potential energy of this ball is equal to 20 joule. And if the ball falls to the ground, if the ball falls to the ground and the ball reach here, when the ball reach here, what is its potential energy? Its potential energy becomes 0. Potential energy becomes 0. Why the potential energy is 0? Because the height is 0, right? Now the ball is on the ground, so its potential energy is equal to 0. So the ball lost its potential energy. So what happened to the potential energy? The conservation of energy, or law of conservation of energy, states that energy cannot be destroyed. So what happened to this potential energy? This potential energy, the 20 joule of potential energy, changed to the kinetic energy of the ball. So kinetic energy of the ball when it reach at the bottom, that is equal to 20 joule. So we can say according to law of conservation of energy, the decrease in potential energy, that is equal to the gain in kinetic energy. Then one more thing, for example, if the ball is rolling down the slope, the ball is rolling down the slope, and when the ball reach here at the bottom, and if the ball reach here at the bottom, the ball is reaching here, so what will be its potential energy? The potential energy, that is equal to 0. Why? Because still now the ball is at the ground, right? The ball is at the ground, so its potential energy is equal to 0. And how much will be its kinetic energy? The law of conservation of energy states that the decrease in potential energy will be equal to gain in its kinetic energy, so its kinetic energy will become 20 joule. So here there is one important thing, that is when the ball is rolling down, we consider that there is no friction. There is no friction. So if there is no friction, then the decrease in potential energy, the loss in potential energy, that is equal to gain in kinetic energy. But if there is friction, what happens is some of the kinetic energy will be lost. Some of its kinetic energy will be lost some of the energy, some of its mechanical energy when it is rolling down, some of its energy will be lost as heat. So the potential energy or the kinetic energy when it reach the ground, the kinetic energy when it reach the ground will be less than 20 joule. Why less than 20 joule? Because some of the potential energy of the ball is lost when it is falling down, when it is rolling down the slope against the frictional force because of the friction. Question number 11. Question 9 and 17 we will discuss together after question 11. So question number 11, that is define mechanical energy as the sum of kinetic energy and potential energy of a system. So what is mechanical energy? That is question number 11. What is mechanical energy? Mechanical energy, that is equal to sum of potential energy and kinetic energy of a system. The mechanical energy of a system, that is equal to potential energy of the system plus its kinetic energy. Okay, so what is mechanical energy of an object? Mechanical energy of an object is equal to potential energy of the object plus the kinetic energy of the object. For example, here we have here we will mark this is our ground, so this height is 0, and here we will another this is at a height of 1 meter, and another level this is at a height of 2 meter, and we have a ball here. We have a ball, and mass of this ball is 1 kilogram. 1 kilogram is the mass of the ball. So what happens is when this ball is at that position, okay, when the ball is at that height, if we consider G equal to 10, okay, for means to make the calculation simple, we will make G equal to 10 Newton per kilogram. So at this height, what is its potential energy? Here its potential energy, that is equal to 1 multiplied mass multiplied G multiplied 2, right? So mgh that is equal to 20 joule. 20 joule is the potential energy. And suppose this ball is at this height, okay, just for example, before we have discussed like this, right? The ball is here, this ball is here, and this is the ground. So this is 1 meter height, this is 2 meter height, and this is the ground is 0 meter. Okay, now the ball is here at rest, the ball is at rest, the ball is stationary. So what is the kinetic energy? The kinetic energy is equal to 0, right? Its kinetic energy equal to 0. Why? Because the ball is not moving. Now the ball is falling, okay, the ball is falling. When the ball is falling, what happens to its potential energy? The potential energy decreases. Why? Because height decreases. Potential energy equal to mgh, right? Potential energy, that is equal to mg multiplied the difference in height. So the difference in height decreases. When the height decreases, its potential energy decreases. Then according to law of conservation of energy, the decrease in potential energy will change into the kinetic energy. So decrease in potential energy will be equal to gain in kinetic energy. So when the ball reach at this height, okay, when the ball falls to the midpoint, when the ball is falling, and when it reach at the middle, for example at the middle that we will draw here. So when it reach at this height, what about its potential energy? Potential energy will become 10 joule, right? Why? Because now the height is decreased to half of the initial height. So initial potential energy was 20 joule. Now the height is only 1 meter. So now the potential energy that is equal to only 10 joule. So what happened to the other 10 joule of potential energy that is lost? That is converted to kinetic energy. So here kinetic energy that is equal to 10 joule. So here also we can write here its potential energy. Here its potential energy that is equal to 10 joule, and kinetic energy also equal to 10 joule. And when this ball reach the bottom, okay, when the ball reach here at the bottom, when the ball reach here at the bottom, what happens to its potential energy? Potential energy is equal to 0, because now the ball is on the ground, right? The ball is at the ground, so its height is equal to 0. If the height is 0, potential energy equal to 0. So what happened to that decrease in potential energy? Now it lost all its 20 joule of potential energy, right? That is converted to the kinetic energy. So kinetic energy that is equal to 20 joule. So when ball reach at the bottom, when the ball reach at the bottom here, its potential energy equal to 0, its potential energy equal to 0, and its kinetic energy that is equal to 20 joule. And we know that what is the mechanical energy? So mechanical energy, that is the sum of the potential energy and kinetic energy of the object. So when the object is at a height of 2 meter, what is its mechanical energy? Its potential energy plus kinetic energy, 20 plus 0. So mechanical energy that is equal to 20 joule. When the ball reach at the midpoint, while the ball is falling, and when the ball reach at the midpoint, what is its what is its mechanical energy? The mechanical energy again is the potential energy plus kinetic energy, right? Mechanical energy is always the sum of potential energy and kinetic energy, 10 joule and 10 joule. So mechanical energy here also it is equal to 20 joule. Here also mechanical energy when it reach at the bottom, that is equal to 20 joule, which means mechanical energy is conserved, or mechanical energy of a system is always a constant. What is mechanical energy? That is the potential and sum of the potential energy and kinetic energy. And when the object is falling, or when the object is rolling down, the decrease in its potential energy will be converted to the kinetic energy of the object. Now we need to discuss question number 9 and question number 17. Question 9 and question 17. Question 9 is apply law of conservation of mechanical energy to solve problems, and question number 17 is apply law of conservation of energy to examples like roller coaster rides, ski slopes, inclined plane, hills, and pendulum, etc. Now we have to discuss question number 17 and question number 9. Question number 17 and question number 9 is to solve problems using the law of conservation of energy. Question number 9 is apply law of conservation of mechanical energy to solve problems, and question 17 is apply law of conservation of energy to examples like roller coaster rides, ski slopes, inclined planes, hills, pendulum, etc. So for example here we will take the first we will take the example of a inclined surface. So here we have an inclined surface, and this is the ground here. This is the ground. So here we have a ball. This ball is at a height of 2 meter, and this ball is rolling down this inclined surface and it reaches the bottom. When ball reaches the bottom, the problems will be, or questions will be like, calculate the speed of the ball using the law of conservation of energy. We need to calculate what is the speed of the ball when the ball reaches the ground by rolling from that height. By using law of conservation of energy, we need to calculate the speed. Law of conservation of energy states that when the ball is rolling down, its potential energy decreases, right? That decrease in potential energy will be equal to the gain in kinetic energy of the ball. So when ball reaches the bottom, it will have a kinetic energy Ke that is equal to how much? That will be equal to its decrease in the potential energy, the decrease in potential energy, the loss in potential energy. So kinetic energy, that is equal to decrease in potential energy of the ball. Kinetic energy we will write half multiplied m multiplied v squared, that is equal to mg delta h. That is the equation for the potential energy, where m is the mass, g is the value of the gravitational field, delta h is the difference in the height. So here in this equation we will cancel this m and m from both sides of the equation, and we have here v squared. So v squared is equal to 2 multiplied g multiplied delta h, and v is equal to square root of 2g delta h. So if you want to calculate the speed here, you have this equation, speed of the ball when it reaches the bottom, that is equal to square root of 2 multiplied g value is 9.8 multiplied the difference in height. Now the difference in height, before it was at a height of 2 meter, now it is on the ground, means the decrease in height or the difference in height is 2. So we will calculate square root of 2 multiplied 9.8 multiplied 2, that equals 6.26. 6.26 is the meter per 6.26 meter per second is the value of the speed. Now we will take the example of a roller coaster ride. So here again we have this is the our ground, this is the ground, and here we have like a toy roller coaster ride, okay, like this. So for example this is at a height of 2 meters here, this is at a height of 2 meter, and here we have a toy car. The mass of the toy car is, for example, 300 meter. Mass of the toy car is 300 gram, sorry, 300 gram or 300 meter. Okay, mass of the toy car is 300 meter, and the value of g that we will take 10, okay, 10 Newton per kilogram. So what will be the potential energy at this point? The potential energy that is equal to mgh, right, mg delta h. So here m is mass is 300. So mass, the SI unit of mass is kilogram, but here mass is given in gram. We need to change that into kilogram by multiplying by 1000. So the mass will be 0.3 multiplied 10 multiplied the change in height is 2. So this will be 6 joule. 6 joule is the potential energy here. 6 joule is the potential energy, and for example this height is 1 meter, okay, 1 meter is this height, and here what is the potential energy that we calculated? Potential energy of the toy car, that is equal to 6 joule. Now when this toy car is rolling down, okay, rolling down, and when it reach here, when the toy car reach here, what will be its potential energy? Here its potential energy will be only 3 joule. Why potential energy is 3 joule? Because now the height is only 1 meter, right, half of the previous height. When height is reduced to half, its potential energy will be reduced to half, because its potential energy was 6 joule. Now its potential energy will be only 3 joule. What happened to that decrease in potential energy? The decrease in potential energy is converted to kinetic energy. So question will be, how much will be the kinetic energy of the toy car here? The kinetic energy of the toy car is 3 joule. How did we get that? We got from law of conservation of mechanical energy. We know that mechanical energy is always a constant, means the sum of the potential energy and kinetic energy must be a constant value. So the decrease in potential energy will be equal to increase in kinetic energy of the object. Now if we take pendulum as the example in the law of conservation of mechanical energy, so here we have a pendulum. Okay, so this is the pendulum, and if you like pull this pendulum to this side, to this, like if you are moving the pendulum like this, so the height of the pendulum is increasing, right? So we will consider here the potential energy that is equal to 0. Potential energy is equal to 0. Now it is increased, right? So it is increased to its maximum height. Now the pendulum is here, so it is increased to its maximum height. So it has maximum potential energy. For example, its potential energy here is equal to, just for example, it is 20 joule. The potential energy is 20 joule. Then it will be at rest here, right? At a maximum displacement. At a maximum displacement, if you displace it to its maximum, when it reach at its greatest displacement, the pendulum will be stationary for a moment. The pendulum will be at rest for a moment. So its kinetic energy will be equal to 0. So what is the total mechanical energy? The mechanical energy is potential energy plus kinetic energy, 20 plus 0, 20. Then what happens is, when you release this pendulum, it moves down, right? When it moves down, its potential energy decreases, correct? Potential energy decreases. Why? Because height decreases. So what happens to that decrease in potential energy? According to law of conservation of mechanical energy, this decrease in potential energy changes to kinetic energy. So when this pendulum reach here at its mean position, its potential energy is equal to 0, but its kinetic energy become 20 joule. This decrease in potential energy changes to its kinetic energy. Then again, what happens? The pendulum will not stop at the mean position. It will go like this, right, to this side, and pendulum again will reach its maximum displacement on the other side. So here, when it go high, you can see its speed decreases, right? Its speed decreases. As its speed decreases, its kinetic energy decreases. When it is maximum displaced, at the maximum displacement, the pendulum will be stationary for a moment. At that moment, its kinetic energy, that is equal to 0. Then according to law of conservation of mechanical energy, the potential energy must be equal to 20 joule. The reason is, the mechanical energy must be conserved, means sum of potential energy and kinetic energy in these three positions must be equal to 20 joule, because its initial potential energy was 20 joule, or initial mechanical energy was 20 joule, right? Potential energy plus means 20 joule plus 0. Now our concept number 6, that is the rotational kinetic energy. So I will just write concept number 6, rotational kinetic energy, rotational kinetic energy. And we have only one question from this section, that is the question number 6. So question number 6 in the EOT is from this topic, the rotational kinetic energy. And in the EOT, relate the rotational kinetic energy to the object's moment of inertia and its angular velocity. This is the question number 6 in the EOT, and it is the page number 207 of your textbook. And question number 37, the rotational kinetic energy. On a playground, some children push a merry-go-round so that it turns twice as fast as it did before they pushed it. What are the relative changes in angular momentum and rotational kinetic energy of the merry-go-round? So what is the relative change in angular momentum? Angular momentum and the rotational kinetic energy. What is the relative change in angular momentum and rotational kinetic energy when the speed of the merry-go-round increases to 2 times? We have this equation for angular momentum that we will represent by the letter L. Angular momentum, that is equal to m multiplied r square multiplied omega. Okay. So here angular momentum L is equal to mr square omega, where m is the mass of the object, r is the radius or distance, and omega is the speed. So when speed increases, okay, when speed you can see here from this equation, angular momentum angular momentum L is directly proportional to omega. So when omega increases to 2 times, when omega changes to 2 omega, then angular momentum will also change to 2 times the angular momentum. So when omega means when the speed changes to 2 times the original speed, 2 times the initial speed, then angular momentum become 2 times the initial angular momentum. So what is the equation for rotational kinetic energy? So I will write Ke rotational, that is equal to half multiplied I multiplied omega squared, where I is called the moment of inertia. I is the moment of inertia and omega is the speed. From this equation you can see the rotational kinetic energy, that is directly proportional to the omega squared, which means when omega changes to 2 omega, means when speed become 2 times the initial speed, then kinetic energy changes to 2 square times the initial kinetic energy. What is 2 square? 2 square is 4, right? So it becomes 4 times the kinetic energy. What if omega changes to 3 omega? What happens to the kinetic energy? The kinetic energy changes to 3 square times the initial kinetic energy. So kinetic energy becomes, what is 3 square? 9, right? 9 times the initial kinetic energy. So here in this question, the question is, on a playground some children push a merry-go-round so that it turns as twice as fast, means the speed of the merry-go-round or speed of the object is increased to 2 times. So what will be the relative change in the angular momentum and the relative change in the rotational kinetic energy? So I wrote the equation of angular momentum. Angular momentum L is equal to mr square omega, which means here omega is the speed, okay? Omega is the rotational speed or angular speed. So we will call omega is the speed. So here from this equation we know that the angular momentum is directly proportional to the angular speed or directly proportional to the speed. So when speed changes to 2 times the initial speed, then angular momentum will changes to 2 times the initial angular momentum. Then we will go to the rotational kinetic energy. So equation for rotational kinetic energy is half I omega squared, where I is the moment of inertia and omega is the speed. So here the rotational kinetic energy, we can, from this equation I am writing the rotational kinetic energy, that is directly proportional to the square of the speed. So when the speed changes to 2 times the initial speed, kinetic energy changes to 2 square times the initial kinetic energy. Why? Because here omega is squared. So 2 square is 4, so 4 times the initial kinetic energy, and if the omega changes to 3 times the omega, then kinetic energy changes to 3 square times the initial kinetic energy. So 3 square is 9, so 9 Ke. Then next we have after rotational kinetic energy, we have the gravitational force, that is law of universal gravitation. And here we have question number 12 and question number 20. So now the next concept is the gravitational force. So this is our concept number 7. Concept concept 5 we need to remove from here. So concept number 7, that is the gravitational force. Gravitational force, and from this concept we have 2 questions, that is question number 12 and question number 20. Question number 12 will be computer exam, right? Question number 20 will be writing. So question number 12 and question number 20. What is question number 12? Question number 12 is define gravitational force as the force of attraction between 2 objects of given mass, just to for writing the definition or studying the definition. And question number 20 is apply the universal law of gravitation to calculate the gravitational force. And here we have given, they have given question number 9 from page number 172 in the EOT. And okay, so we will discuss these two questions now. What is the law of universal gravitation? Law of universal gravitation states that when there are two objects, for example this blue color marker and this red color marker, so the Newton's universal law of gravitation states that these two marker or these two masses, they attract each other. They attract each other, and that force of attraction is called gravitational force. So this Newton's law of universal gravitation, which gives an equation to calculate the gravitational force between two masses. For example, here we have an object, its mass is m1, we will write, and at a distance r we have another object, its mass is m2, another object, its mass is m2. So we have two objects m1 and m2. They are separated by a distance r. R is the distance between them. So the distance is always from center of one object to the center of the other object, center of one mass to the center of the other mass. Okay, so the universal law of gravitation states that these two objects attract each other with a force, and that force is equal to g m1 multiplied m2 divided by r squared, where g is a constant, it is called a gravitational constant, and the value of g is 6.67 times 10 to the power negative 11. m1 is mass of one of the object, m2 is the mass of the other object, and r is the distance from center of one object to the center of the other object, distance from center to the center. And from this equation you can see the gravitational force is directly proportional to the product of the masses, which means when mass increases, the gravitational force will increase. And this r square is in the denominator, which means when the distance between these two masses increases, when the separation increases, when distance between these two marker increases, the attraction, the force of attraction between them decreases. When distance increases, the force decreases. Okay, so here for example, when one mass, okay, when one of the mass m1, so m1 doubled, means m1 made into 2m1. We are not changing m2, okay, we are changing only m1. So what is the change in the gravitational force? The change in the gravitational force F is equal to, we know that the gravitational force is directly proportional to the mass, right? So when one mass changes to 2 times, the gravitational force will become 2 times, it will increase by 2 times. When the second mass m2 also changed, when both the masses are changed, okay, when both the masses doubled, means m1 is doubled, m2 also doubled. So here because of m2, the gravitational force become 2 times again. So what will be the total effect? The total effect is gravitational force became 4 times, right? So when only one mass is increased to 2 times, gravitational force become 2 times. When both the masses increase to 2 times, the gravitational force become 4 times. Okay, then what happens when you decrease the distance between the mass? What happens to the force when you decrease the distance between the masses? The force will increase, right? When the distance decrease, the force will increase. Why? Because distance is in the denominator. So when the quantity in the denominator decrease, the force will increase. So for example, when this r decreased to r by 2, then what happens to the force? times will it increase? You can see r is squared, right? So force will increase by 2 squared F. What is 2 squared? 2 squared is 4, right? So force will change by 4 times F. So here you can see when you increase both the masses, okay, you increased this mass to 2 times, this mass also to 2 times, and you decrease the distance to the half of the previous distance, half of the initial distance, then the total change in the force will be 8 times. The force increases by 8 times. Okay, do you understand this? What I said is we will do it separately. Okay, just like when you increase only one mass, when you increase means when you double only one of the mass, force become double. If you increase both the masses to 2 times, means if you double both the masses, then the gravitational force become 4 times. Gravitational force become 4 times. Then next what I said is, if you reduce the distance, if you decrease the distance between the mass, gravitational force will increase, right? So if you make the distance between the masses to half of the initial distance, means if you reduce the distance to the half, then gravitational force will increase by 2 square F. Why 2 squared? Because gravitational force is inversely proportional to, the force is inversely proportional to square of the distance. So 2 squared into F. 2 squared is 4, right? Then if you make all these changes, like you doubled both the masses and you decreased the distance, you reduced the distance to the half, so all these 3 changes you made, then the total change in the gravitational force become 8 times. The next is, we know that when you increase the distance between the masses, okay, so means you move the masses away, which means you are increasing the distance between the masses. When you increase the distance between the masses, we know that the force will decrease, right? When you increase the distance, the force will decrease, because you can see the force is inversely proportional to square of the distance. Why inversely proportional? Why I say inversely proportional? It is because the distance is in the denominator of the equation. So for example, when we increase the distance, we know that the force will decrease. Okay, now r is increased to 2 times r. What will be the change in the force? Force will change, force will decrease, right? That is sure, force will decrease. When you increase the distance, force will decrease. Force will change by F divided by, you can see here r is squared, right? So 2 squared. What is F by 2 squared? 2 squared is 4, right? F by 4. So when r changes to 2r, F changes to F by 2 squared. F by 2 squared is 4. So when r changes to 3r, when r changes to 3r, F changes to F divided by 3 squared. The force reduces, right? Force become F by 3 squared. How much is the F by 3 squared? Which is F by 9. So when you increase the distance to, means when you make the distance 4 times, you are increasing the distance by 4 times, 4r. So what will be the change in the force? Force changes to F divided by 4 squared. How much is 4 squared? 4 squared is 16, F by 16. So this is the meaning of inverse square law. F is inversely proportional to square of the distance, means when the distance increase, the force will decrease. When distance become double, force become F by 4. When distance become 3 times, force become F by 9. When distance become 4 times, force become F by 16. Now we will use this equation to solve questions. So here we have a question number 9 from the textbook. Question number 9 from the page number 172 of the textbook. Mathematical representation: predict the gravitational force between two 15 kilogram balls whose centers are 35 centimeter apart, and what fraction is the weight of one ball. Okay, that is very easy question. So here we have two masses, I think two ball. What is the mass of the ball? Both are 15 kilogram. 15 kilogram, its mass is 15 kilogram, and this mass also 15 kilogram. What is the distance between them? The distance between them is 35 centimeters. So distance r is equal to 35 centimeter, and this is the equation to calculate the gravitational force, that is equal to the value of g is 6.67 times 10 to the power negative 11 times 15 times 15 divided by square of the distance. What is the distance? 35 centimeter. But centimeter is not the SI unit of distance, meter is the SI unit of distance. So you have to change this centimeter to meter. How? By dividing by 100. So 35 divided by 100 will be 0.35. So this is 0.35 squared. Now we will do the calculation. So 6.67 times 10 to the power negative 11 times 15 times 15 over 0.35 squared. So the value is 1.23 times 10 to the power negative 7. The answer is 1.23 times 10 to the power negative 7. Unit of force is Newton. And there is a sub question here. What fraction is this of the weight of one ball? So this is the gravitational force, right? So we got the gravitational force, that is 1.23 times 10 to the power negative 7 divided by weight of one of the ball. So weight of one of the ball is 15 mg, right? Mg is the weight. 15 multiplied 9.8. So which equals, so our answer, the answer we got, divided by 15 multiplied 9.8, that equals, so 8.33 times 10 to the power negative 10. 8.33 times 10 to the power negative 10, which just shows that the gravitational force, the value of the gravitational force or strength of the gravitational force is very less compared to the weight of this one of the mass. That is what we have done here, and this is how we calculate the gravitational force. Okay, this is how you need to calculate the gravitational force. And next is section 18, means how to calculate the, or concept number 18. Okay, how to calculate the gravitational field. How to calculate the gravitational field, that is the concept number 8, to calculate the gravitational field. And we have one question from this. Yes, one question, that is question number 14. Question number 14, concept 8. Okay, to calculate the gravitational field, not force, gravitational field. And here we have question number 14 from the EOT. Question number 14 from EOT to calculate the gravitational field. We know that every mass produces gravitational field around it. For example, this mass, it has a mass, right? So it will have a gravitational field around it. Its mass is very small, so its gravitational field also very small. So if I take Earth as an example, Earth. So this is Earth, it has a very large mass. So it produces a gravitational field around this. So there is a gravitational field around Earth, and the strength of the gravitational field will be greater, or the gravitational field will be stronger here at the surface. Gravitational field will be stronger at the surface, and if we move away from the surface, like if we move away from the surface, the strength of the gravitational field decreases. And here, if you want to calculate the gravitational field at the surface, or if you want to calculate the gravitational field at a point that is about like x kilometer away from the surface, you have the equation. So what is the equation to calculate the gravitational field? The equation to calculate gravitational field, G equal to G multiplied m divided by r squared. So what does this g represent? This g, the small letter g, represent the gravitational field strength. The small letter g represent gravitational field strength. So here g is the strength of the gravitational field, strength of the field I will write. And what is g? The value of g is 6.67 times 10 to the power negative 11. G is a universal constant. It's a universal gravitational constant, which means its value will be always 6.67 times 10 to the power negative 11. And what is this m? M is mass of the object which is producing that gravitational field. Here Earth is producing the gravitational field. So in this example, m is the mass of the Earth. And what is r? R is the distance. If you are calculating the gravitational field here at the surface of the Earth, r is equal to distance from the center of the Earth to this point. But if you are calculating the gravitational field at this height, for example 300 kilometer away from the surface of the Earth, then r is the distance from center of the Earth, means this distance, radius, right, that you need to add. Okay, means r from the this distance is the distance, r is the distance from the center of the Earth to this point up to here. Now we will discuss one question from the textbook. Question number 14. Okay, question number 14 of the Heikel. Question 14 of the Heikel. So we have one question, that is question number 20 from page number 181, that is given in the Heikel. Gravitational field. The mass of moon is 7.3 times 10 to the power 22 kilograms. So here we have a moon. So this is the moon. So moon produce a gravitational field around this. What is the radius of the moon? The radius of the moon is 1738 kilometer. 1738 kilometer is the radius. And the mass of the moon is that is equal to 7.3 times 10 to the power 22 kilogram. That is the mass of the moon. And the question is, what is the strength of the gravitational field on the surface of the moon? So strength of the gravitational field on the surface of the moon, that we have to calculate. So we have this equation, right? Gravitational field G equals Gm divided by r squared, where G is 6.67 times 10 to the power negative 11 times this mass. Here mass is mass of the object, mass of the planet, or mass of that satellite, or mass of the moon which is producing that gravitational field. Here moon is producing the gravitational field, so this m is mass of the moon. So here we have to write 7.3 times 10 to the power 22 divided by square of the distance. So what is the distance? Distance from the center to the point where you want to calculate the gravitational field. So here you are calculating the gravitational field at the surface. So distance is equal to radius of the moon. So it is 1738 kilometer, right? We need to change that kilometer to meter by multiplying by 1000 and square, which equals, now we will do the calculation. So here 6.67 times 10 to the power negative 11 multiplied 7.3 times 10 to the power 22 divided by 1738 multiplied 1000 squared. So the answer is 1.61, and the unit of gravitational field is Newton per kilogram. So again, if you want to calculate the gravitational field at a point, not at the surface. Okay, if you want to calculate the gravitational field that is at a point here, if you want to calculate the gravitational field here, for example, this is at a distance about 200 kilometer from the surface of the moon. So how to calculate the gravitational field here? So in that, first you need to calculate the distance r. Here distance is not equal to radius, right? Because this is the radius plus this much distance. So what is the total distance here? Distance is 1738, that is distance from here to here, plus the distance from the surface of the moon to this point, that is 200. So this will be 1938 kilometers. So how to calculate the gravitational field at this point? At this point, gravitational field G equal to gm divided by r squared. Here r is the distance from the center of the moon to this point, distance from center of the moon to this point. So here we will substitute the same values. Okay, so 6.67 times 10 to the power negative 11 times mass of the moon, that is 7.3 times how much, 10 to the power 22 divided by 1938 into 1000 squared. So the value of gravitational field will be less than 1.61, because when distance is increased, right? So when distance increases, the strength of the gravitational field decreases. So here it is 6.67 times 10 to the power negative 11 times 7.3 times 10 to the power 22, right? 22 divided by 1938 multiplied 1000 squared equals, now I am getting 1.3. So you can see that here 1.3 Newton per kilogram means when the distance is increased, the strength of the gravitational field is decreased. Okay, so what is the strength of gravitational field on the surface of the earth? That is equal to 9.81. So if you go away like 300 kilometer, 500 kilometer above the surface of the earth, the strength of the gravitational field will decrease. Now we have two more concepts remaining, concept number 9 and 10. The concept 9 is to calculate the orbital speed and orbital time period of planets and satellites. So we will discuss this concept number 9, to calculate the orbital speed and orbital time period of planets and satellites. So here concept number 9, to calculate orbital speed and time period of satellites and planets. So here we have in section 9 we have two questions, question number 13 and question 15. Question number 13 and 15 from the EOT, from the Heikel. Okay, so first I will write the equation to calculate the speed and time period. Okay, so the equation to calculate time period T is equal to 2 pi into square root r cube divided by gm, and orbital speed v is equal to gm square root gm divided by r. So this is the two equation, right? Square root gm divided by r. To calculate the orbital speed and the time period is equal to 2 pi into square root r cube over gm. Here for example we have sun here. Here we have sun, and there is a planet that is moving around the sun. So here we have the planet For example, this planet is the Jupiter. So here in this equation, to calculate the orbital time period means the time taken by Jupiter to complete one rotation around the Sun. For Earth it is 365 days. So what is the time period equation? T is equal to 2 pi into square root of r. What is r here? R is the orbital radius. That will be given like this. Okay, orbital radius. R is the orbital radius, means the distance from center of the Sun to the planet. Then what is g? G is universal gravitation constant. Its value is constant everywhere all the time. That is 6.67 times 10 to the power negative 11 that we used in the previous questions. And the point is, what is this m? What is this m? Mass of Jupiter or mass of the Sun? That is the thing that you need to understand. This m is mass of the Sun. Okay, mass of the Sun. So here you have to think like that. M is the mass of the object that is at the center. For example, here we have Earth and Moon is orbiting around the Earth. Moon is rotating around the Earth. So in this equation, to calculate the orbital time period of Moon to complete one rotation around the Earth, this is the equation. So in that equation, what is m here? M is mass of the Earth, mass of the object which is at the center of the orbit. Mass of the object, or mass of the object, yeah, which is at the center of the orbit. So here this is the mass of the Earth you need to use in this equation. And this equation also, m is when you are calculating the orbital speed. When you use this equation, m is the mass of Earth here. And if you are calculating the orbital speed of this planet Jupiter, so m is the mass of the Sun. Okay, if you are calculating the time period and orbital speed of a satellite, m is the mass of Earth or mass of the planet. And if you are calculating the time period or orbital speed of a planet, then m is the mass of the Sun. So a question to calculate the Neptune's orbital time period. So here the mass of the Sun is given in this question. Mass of Sun is given as, mass of the Sun is given, mass of Sun that is equal to 1.99 times 10 to the power 30 kilogram, 10 to the power 30 kilogram, that is the mass of the Sun. And the radius is given. Okay, the orbital radius is given, means the distance from center of the Sun to the Neptune, the planet Neptune, that is equal to 4.496 multiplied 10 to the power 12 meter. That is the value of the orbital radius. And the question is to calculate the orbital time period. We need to calculate the orbital time period. The equation to calculate orbital time period T, that is equal to 2 pi into square root r cube over gm. So here 2 pi into square root r cube, the orbital radius cube, that is 4.496 times 10 to the power 12, which is cubed, divided by gm. The value of g is 6.67 times 10 to the power negative 11 times m. Here m is the mass of the Sun, right? Mass of the Sun is 1.99 times 10 to the power 30, which equals, now I will use the calculator. So 2 multiplied shift pi multiplied square root 4.496 times 10 to the power 12 cubed divided by 6.67 times 10 to the power negative 11, 10 to the power negative 11 times 1.99 times 10 to the power 30 equals, I am getting 5.2 times 10 to the power 9, 5.2 times 10 to the power 9. So here we used all in SI unit, right? We used the distance r in meter, we used mass in kilogram, so we used all in SI unit, so we will get the answer in SI unit. Time period we got in seconds. So if you want to change this into years, so how to change this into years? 5.2 times 10 to the power 9 divided by, if I, this is in seconds, right? So if I divide by 60, this will change into minutes. Again 60, this will change into hours. So again 24, it will change into days, and if again 365, then it will change into earth years. So divided by 60 multiplied 60 multiplied 24 multiplied 365 equals 165 years, 165 years. So for the earth to rotate or to complete one rotation around the sun, it takes 1 year, right? It takes 1 year. For the Neptune to make one rotation around the sun, it takes 165 earth years. The next is question number 15 from the EOT. Question number 15 from EOT. This is example problem 2, orbital speed and period. Assume that a satellite orbits the Earth 225 km above the surface. Given the mass of the Earth and the radius of the Earth, what are the satellite's orbital speed and period? So we need to calculate the orbital speed and period of the satellite. So we have given this data. So here we have Earth, and the radius of the Earth is given. Radius of the Earth is given. Radius of the Earth, that we will just write capital letter R. And what else is given? This satellite is at a distance of 225 km above the surface of the Earth. So the satellite is not on the surface, it will not be on the surface, right? Satellite is at a height of 225 km above the surface of the Earth. So here is the satellite. So this is our satellite. Satellite is here, 225 km above the surface. And what is the mass of the Earth? Mass of the Earth is given. Mass of the Earth is equal to 5.97 times 10 to the power 24 kilogram. 5.97 times 10 to the power 24 kilogram, that is the mass of the Earth. And the radius of the Earth, that is equal to, radius of the Earth is 6.38 times 10 to the power 6 meter, that is the radius of the Earth. First we need to calculate the orbital speed. Okay, the equation to calculate orbital speed, V is equal to square root of gm divided by r. From this equation you can see that the speed is inversely proportional to the square root of the distance, which means the speed will decrease. The speed will decrease when distance increases, right? When distance of the satellite from the Earth's surface increases, the speed decreases. Or we can say like this, for a solar system, the planets near to the sun move faster. The planet near to the sun move faster, and the planet away from the sun move slowly. Its speed will be less. If the planet is at more distant away from the sun, the speed of the planet will be less. That is what this equation tells. Speed is speed will decrease when distance increases. Okay, so we need to calculate the speed. So we will substitute values in this equation. We know that square root of, we know the value of g, right? 6.67 times 10 to the power negative 11 times. We know the mass of earth. So we said, like, when you are calculating the speed and time period, we need to use the mass of the, like, the object which is at the center of the orbit. So here the earth is at the center and the satellite is moving around to the earth. So we need to use mass of the earth, not mass of the satellite, and mass of the satellite not even given. Okay, 5.97 times 10 to the power 24 mass of earth divided by distance. So like r, right? R is the, you think that r is the radius, right? Yeah, it's correct, r is the radius, but not the radius of the earth, it is the orbital radius. So if you see in the question, radius of earth is 6.38 into 10 to the power 6, you should not use that value here for the r. This r is the orbital radius, this r is the orbital radius. So what is the orbital radius? Orbital radius is distance from the earth's center to the satellite. So how much? 6.38 into 10 to the power 6 plus 225 into 10 to the power 3, right? Because we need to change that into meter. So I will just add that 6.38 multiplied 10 to the power 6 plus 225 multiplied 10 to the power 3. That equals 6.61 into 10 to the power 6. 6.61 into 10 to the power 6. That is the value of r. No need of bracket. Okay, I just put it. So here, how did we get? We added, right? We added this radius plus this 225 kilometer, like this. R is equal to 6.38 into 10 to the power 6 plus 225 into 10 to the power 3, or 1000. Why 1000 multiplied by 1000? It is because here the distance is given in kilometer, that we need to change into meter. So when we add this, we will get 6.61 times 10 to the power 6. Okay, that value I used here. Now we will check what is the orbital speed. So here orbital speed is square root of 6.67 times 10 to the power negative 11 times 5.97 times 10 to the power 24 divided by 6.61 times 10 to the power 6. 6.61 times 7.76 into 10 to the power 3. So the speed is 7.76 times 10 to the power 3 meter per second. That is the orbital speed. Now we need to calculate the orbital time period. What is the equation to calculate orbital time period? You don't have to worry about the equation, right? The equation also will be given in the exam. So orbital time period t, that is equal to 2 pi into square root of r cube over gm, which equals 2 pi into square root of r cube. R we calculated, right? 6.61 orbital radius, 6.61 times 10 to the power 6 cubed divided by 6.67 times 10 to the power negative 11 times mass. Here mass of the earth, that is 5.97 into 10 to the power 24. 5.97 times 10 to the power 24 equals square root 6.61 times 10 to the power 6 bracket close cubed okay, divided by 6.67 times 10 to the power negative 11 times 5.97 times 10 to the power 24, which equals 8.52 into 10 to the power 2 seconds. 8.52 into 10 to the power 2 seconds. Okay, so I think I forgot to multiply with 2 pi. Did I? Yeah, I didn't multiply this with 2 pi. Okay, so this is not the answer. We need to multiply this value with 2 pi. So okay, 8.52 times 10 to the power 2 multiplied 2 times shift pi equals 5.35 into 10 to the power 3. 5.35 times 10 to the power 3 seconds. Now we are discussing the last concept of this EOT, that is concept number 10, pressure, and we have only one question from this, that is question number 16. So now we are discussing about pressure, and we have question number 16 from the EOT from this topic, pressure. So the question number 16, example 1 in page number 234 of your textbook, recall as the pressure perpendicular component of force divided by the area. So here pressure is equal to, what is pressure? What is the equation to calculate pressure? Pressure is force divided by area. Pressure is force divided by area. What is the unit of force? Unit of force is Newton and unit of area is meter squared. So unit of pressure is unit of pressure. Unit of pressure is Newton per meter squared. Newton per meter squared is called Pascal. Newton per meter squared is called Pascal, and we represent Pascal by writing PA. So that is the SI unit for pressure. Then example problem 1 from the textbook, calculating pressure. A child, his weight is 364 Newton and sits on a 3-legged stool which weighs 41 Newton. The bottom of the stool's leg touch the ground over an area of 19.3 centimeters squared. What is the average pressure that child and the stool exert on the ground? The child and the stool exert on the ground, right? So in this question we have a child, its weight is 364 Newton. So to calculate pressure, first we need a force. How much is the force acting onto the ground here? So here the total force acting onto the ground, that is 364, that is the weight of the child plus the weight of the stool. How much is the weight of the stool? 41 Newton, which is equal to 364 plus 41, that will be 405 Newton. 405 Newton, and to calculate the pressure we need area also. So how much is the area of contact? Here area of contact is 19.3 centimeters squared. That is the area of contact of the stool's 3 legs. So 19.3 centimeters squared. So here is the main calculation that you have to do, that is pressure is equal to force divided by area, that is force is equal to 405 Newton divided by area, that is 19.3 centimeters squared, but you need in meter squared, right? The unit of area is meter squared. So how to change centimeter to meter? Divide by 100. So how to change centimeter square to meter square? Divide by 100 2 times. So this one, when you change into meter squared, 19.3, if you are converting centimeter to meter, divide by 100, right? But centimeter square to meter square, so 2 times you need to divide by 100. So when you do that, this become like this, 1.93 times 10 to the power negative 3, which equals 405 divided by 1.93 times 10 to the power negative 3, that is 2.1 times 10 to the power 5. 2.1 times 10 to the power 5 unit of pressure is Pascal. Then what the child is doing, the stool has 3 legs. How does the pressure change when the child leans over so that only 2 legs of the stool touch the floor? When only 2 legs of the floor, when only 2 legs of the stool touch the floor, what about the area of contact? Area of contact decreases, right? Because now only 2 legs are touching the ground. So when area of contact decreases, what happens to the pressure? Pressure will increase. Whatever in the denominator decrease, then the left side, means the pressure here, that will increase. Then we have some practice problems from the textbook, that is question number 1. The atmospheric pressure at sea level is about, okay, so the atmospheric pressure at sea level is about 1.0 into 10 to the power 5 Pascal. So here pressure is given, okay, in this question pressure is given, that is equal to 1.0 times 10 to the power 5 Pascal is given as the value of pressure. What is the force at sea level that air exerts on the top of a disc, and the area of the disc is given like this. It is 150 centimeter, 152 centimeter long and 76 centimeter wide, 76 centimeter wide. So when you multiply, you will get the area in centimeter squared, but what we will do is we will change each into meter, okay. So it will be 1.52 meter multiplied 0.76. So how much is the area? So when you multiply that, you will get area in meter squared, 1.52 multiplied 0.76. So area that is equal to 1.16 meter squared, 1.16 meter squared. You want to calculate what do you have to calculate the force. So force is equal to, you can see force is equal to pressure multiplied area, right? Pressure multiplied area, because like this, right? Force that is equal to pressure multiplied area, means if you want to calculate pressure, force over area, so force pressure multiplied area, okay. Pressure multiplied area, here pressure is 1.0 into 10 to the power 5 multiplied area is 1.16, which equals, so 1.16, right? So it become 1.16 into 10 to the power 5. Force, the unit of force is Newton. Another question, a car tire makes contact with the ground on a rectangular area of 12 centimeter by 18 centimeter. So area of the car tire, that is equal to how much? The area is 12 centimeter by 18 centimeter. So we will convert that into meter. So it will be 1.12 multiplied, 0.12 multiplied 0.18 meter squared. If the car's mass is 625 kilogram, what pressure does the car exert on the ground as it rests on all 4 tires? As it rests on all 4 tires, the area of contact of one tire is this much. So there are 4 tires, so multiplied by 4 we will get the total area of contact. Total area of contact, that is equal to 0.12 multiplied 0.18 multiplied 4 equals 0.12 multiplied 0.18 multiplied 4, 8.64 multiplied 10 to the power negative 2, 8.64 multiplied 10 to the power negative 2 meter squared. That is the area of contact of all the 4 tires of the car. And here force is not given in the question. Instead of that, mass is given. So how much will be the force acting on the ground? That will be equal to weight of the car. So it is, mass is 925, its weight will be 925 multiplied by 9.8, that equals 925 925 multiplied 9.8, 9.07 into 10 to the power 3, 9.07 times 10 to the power 3, unit of force is Newton. So what do you have to calculate? You have to calculate the pressure, right? So pressure P is equal to force divided by area. Force is 9.07 times 10 to the power 3 over area, that is 8.64 times 10 to the power negative 2, which equals divided by 8.64 times 10 to the power negative 2, 1.05 into 10 to the power 5 Pascal. 1.05 times 10 to the power 5 Pascal is the value of the pressure. Now we have completed discussing all the 20 questions from the EOT, and my advice or my suggestion for attending the paper exam: when you do the paper exam and if you do not know any answer, if you don't know the answer of any question, never keep that space blank. You write the equation. The equation will be given in the first page. So you write the equation from the first page. If you do not know the answer, write the equation. So if you do not know which one is the correct equation, right, because many equations will be given, right, in the first page. So what you have to do is write all the equations. Okay, my point is, do not keep the space blank. Write the equations, and if still there is space, you write what is given in the question. Write what is given in the question. Never leave the space blank without writing anything. Write it, make it full. Okay, so attempt all the questions in the paper exam. There will be 6 questions, right? 4 questions and 2 bonus questions. So if you do not know the answer, do not leave the space blank. Write the equation. Equations will be given in the first page. So write means go to the first page, see the equation, write the equation on the paper for all the questions. Okay, if you do not know the answer, then you may think which equation is correct. No need to think which equation is correct. If you don't know which equation is correct, write all the equations there. One equation will be correct, right, from that. And write what is given in the question. Like for example, they may be given like 2 meters 5 kilogram, then just write 2 meter 5 kilogram, like that. So make the space full. Okay, do not leave it blank. Thank you for watching this video, and I want to wish you a good luck for your examination, and I want you, all the viewers of this video, all the students watching this video and the other students, to get full mark in the examination. And after your examination, when you get the result, or after your examination, if you feel this video is helpful for your studies, you can write it in the comment. Thank you for watching.